Yellowstone supervolcano warning. Giant magma chamber found under the surface about 3 to 5 miles down. And the Mantle Plume hotspot connections. According to USGS, the Yellowstone hotspot has been suspected to be part of a mantle plume, a region of the mantle that is hot but still solid and that is buoyantly upwelling. Mantle plumes may originate from the boundary between Earth's mantle and core, nearly 3,000 kilometers, about 1,850 miles beneath the surface. And USGS says the source of Yellowstone's heat. Just how long has the Yellowstone hotspot been around? We know that the mantle plume comes from basically Baja California and goes into the area, as we see from the map here, into Salt Lake City up to Yellowstone, and then turns west under Idaho. Now, Yellowstone Caldera Chronicles says Yellowstone sits above the melting anomaly within the Earth called a hotspot. This hotspot is powered by a plume of hot but not molten material that may extend as deep as the boundary between the planet's mantle and the core, according to USGS. And as hot material rises buoyantly, it decompresses and melts near the surface, generating magma that feeds the magma chamber beneath Yellowstone and thus provides the heat that powers the many geysers and hot springs. Yellowstone, as we know, is one of the 21 supervolcanoes of the Earth. It has over 60% of the world's geysers and over 10,000 hydrothermal areas. The hotspot is stationary relative to the moving tectonic plates that make up Earth's surface. As the North American plate moves to the southwest over the hotspot, the center of the volcanic activity therefore appears to be migrating to the northeast. There's thus a trail of volcanism that stretches to the southwest from present-day Yellowstone across the Snake River Plain of southern Idaho, getting progressively older along the trend. And these older volcanic centers are essentially ancient Yellowstones, and some were responsible for especially powerful eruptions. The start of the trail is 17 million years old, McDermott volcanic system and similar age volcanism in northern Nevada and southern Oregon. Yellowstone-style volcanic eruptions weren't the only thing happening 17 million years ago. That time period also saw the eruption of the Columbia River basalt, a tremendous outpouring of lava from vents in eastern Oregon and Washington and western Idaho. The lava from these vents flowed all the way to the Pacific Ocean and is responsible for some of the impressive features along the Oregon coast. For many years, it was assumed the Columbia River basalt eruptions represented the start of the Yellowstone hotspot. The first eruptions of the hotspot would likely be voluminous, since the head of a mantle plume would be charged with heat and induce tremendous melting. There was no obvious signs of older volcanic systems to the southwest of McDermott age volcano centers. The trail essentially went cold. Now, preserved in the coastal mountains of Oregon and Washington is evidence of massive volcanic eruptions that occurred offshore about 50 to 55 million years ago. Some of the lava from these eruptions was scraped up and welded onto the North American coastline by subduction, and still more exists on the ocean floor offshore of the Pacific Northwest. So, now this so-called silesia terrain has chemical and physical characteristics that suggest it formed due to the mantle plume, and it has a composition similar to the Columbia River basalts, indicating that the two large lava flows provinces are related. Might the silesia terrain have formed due to an early version of the Yellowstone hotspot? If it's true, then North American continent would begin to override the hotspot about 40 million years ago. And sure enough, there are volcanic rocks of this age in Oregon and Washington Coast Range that are chemically related to the older silesia rocks and younger Yellowstone hotspot production. These related rocks of the hotspot were originally welded onto the North American continent in coastal California and Oregon, but since that time, tectonic forces caused northward migration of the rocks by as much as 300 kilometers to their current position in coastal Oregon and Washington. Volcanism presumed to be driven by heat from Yellowstone plume continued east to the Cascade Mountains in southern Oregon and northern Nevada during 20 to 30 million years ago as the North American plate continued to move over this ancient Yellowstone hotspot. But these eruptions declined dramatically about 22 million years ago and stopped altogether 20 million years ago, beginning the hiatus of several million years. And this pause ended the eruption of the Columbia River basalt. So what happened? What stopped the eruptions 20 million years ago? The most likely culprit is a slab of previously subducted ocean crust, the Pacific plate going under the North American plate, which was uplifted by the buoyant plume and trapped beneath the North American continent. This barrier effectively blocked the flow material from the Yellowstone hotspot to the surface. Magma is still being generated, but it was backed up behind the barrier. The accumulated magma finally punched through 17 million years ago, breaking the ancient slab and resulting in the Columbia River basalt eruptions. Then began the progression of volcanic calderas to present-day Yellowstone. About 20 years ago, this story might have been dismissed as fantasy. Through the years of careful accumulation of data and evidence, though, the case has become quite strong. The Yellowstone hotspot is a long-lived feature that dates back to at least 50 million years and perhaps even earlier. This evolution is thought is a good example of how continued data collection and study are critical and can shift our view of geological history, even changing our understanding of something as important as the Yellowstone magmatic system. And this was from USGS Caldera Chronicles concerning what happened. This is a recent article, January 31st, 2021, well, about a year ago. But concerning the hotspot, their warning, the researchers found a giant magmatic chamber beneath the surface. Now, the last super eruption was about 630,000 years ago, 1,000 times bigger than Mount St. Helens eruption of 1980. And here, light and hot magma from Mantle rises towards the surface with the hotspot deep beneath the surface, so deep that the North American plate slides west-southwest over it. And over the past 17 million years, this hotspot generated a succession of explosive eruptions, but less violent floods of basaltic lava. And today, scientists and researchers closely observe Yellowstone for signs it may be gearing up for another eruption. It's generally accepted that an eruption in the next 10,000 years is not likely. Now, in 2015, scientists collected new data which gave them the best idea yet of Yellowstone's underground plumbing. Identifying the volcano's magma chamber from the last eruption, they discovered how it was being fed by the plume of magma, stretching down 465 miles northwest into Montana, mostly solid rock, but with a potential to liquefy. And using the data, geologists created a graph showing a giant yellow stalk shooting off into the ground far away from Yellowstone's surface. And it's thought that the plume, that magma or molten rock, is rising up into the magma chamber at the rate of 2 inches a year. So this is a 2-inch year rising into the magma chamber. There's no reason for this process to stop, they said, and eventually will continue until the pressure becomes too much and the volcanic eruption occurs, or it could come in short, sharp spurts. While this is unsurprising, what scientists are paying close attention to is the liquidation process. The real danger comes when the plume starts liquefying, moving up at a faster rate. On erupting, Yellowstone's magma is unlikely to turn into lava because the intensity of an eruption would force most of it to shoot into the sky, and then it would take the form of airborne ash particles, small, extremely hot pieces of jagged rock. So in this event alone would affect nearly all of the US and Canada, with tens of millions of people within a 620-mile radius at risk of death. And once the ash was breathed in, of course, it would become cement-like mixture in people's lungs. So with those outside the 620-mile radius or 1,000-kilometer range may be safe from immediate aftermath of eruption, and a centimeter of ash would still have fallen, still a dangerous level for human lungs. So the magma is increasing at 2 inches a year. Some scientists and organizations have spent years hatching plans to stop any Yellowstone eruption from occurring, and NASA, we said in the past, wanted to cool it down, but that would take thousands of years to do so. So one report, NASA plan involving drilling the 10-kilometer hole 6 miles down into Yellowstone, pumping water to release the high pressure. This would circulate the water, returning it at an estimated temperature of 350 degrees Celsius or 662 degrees Fahrenheit, slowly day by day extracting heat from the volcano. But Michael Pollan, who's the geologist in charge of Yellowstone, has stated many times that as long as he's in charge of Yellowstone, no one's going to touch Yellowstone doing things like this. This is from Caldera Chronicles of USGS and also Joel Dave Express UK. Please leave your comments and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.